Hi everyone. Good morning, good afternoon, wherever you are. Thanks for having me here. Today, I'll be discussing on the topic of maturing your software supply chain security. A little bit about me. I am a product security consultant with more than 14 years of experience in security. I have worked in both offensive and defensive security, and mostly been focused on lately working on and establishing security practices and also maturing them for a lot of product security and development teams. So the agenda, I wanted to keep it simple. I want to talk about four main aspects today, which will help us understand how maturity can take place. First, the software supply chain architecture itself. So we'll understand what constitutes the software supply chain architecture, what is the attack surface look like. Then we'll look at the threats and what all of these recent threats have been pointing towards. Then we look at what are the nitty-gritties of and basics of the right kind of techniques that we need to follow to have security in our software supply chains. And lastly, we look at how do we mature that, how do we track that and grow in that and evolve going forward. So first of all, when we look at the software supply chain itself, keeping it simple, while there are many components which might come in, there are essentially, I like to divide it into three main zones, which is three functional zones. First of all, the source itself, where you will have all your custom code, you will have your dependencies, libraries, all of that coming in and being pulled into the main code to be developed by the dev teams. Then there is the dev and the build and the test zone. This zone will basically have a lot of activity going on, right? It will have the functional tests, it will have the security scans, checks, reviews, all of that, which is there in the build stage itself. And then putting it a little more loosely, you have your artifacts which are created from there. You create your containerized artifacts essentially, and then you have your deployment and post deployment activities that go on. So these are the three main stages, and in the entire conversation, we'll mostly be referring to these three stages or three functional zones in the architecture for your supply chain. So while you have all of these different zones, we have to understand that particularly with respect to these different stages in your agile development, which as you can see here from planning, code, test to the monitor phase itself, you will be working with, as a development team, you'll be working with a lot of different components which are there. And these components may not necessarily be your custom code, which means that there are a lot of products, first of all, that we are working with as developers. So it could be the ones that are helping us to write the code itself, or the ones that are helping us to host the code. So there are some of those where you have these IDs, there are different tools that we use during development and all of that, which become a part of the overall supply chain. Then you have the SaaS products which come in where, for example, Git and other source code and versioning systems where you upload your code, which help you manage and version your code better. And there are many other such SaaS products as well. There will be contributors. So in case of open source products that you're creating, you'll also have external contributors contributing code, which will then become a part of your overall product. You have different libraries, dependencies that you fetch. There are images from different public registries that you might be pulling in. There are third-party APIs that you might be consuming. And this is not an exhaustive list. So there can be a lot of these different components in your overall supply chain architecture that you yourself are working for your product. Now, when you look at it, you understand that while there are so many products, each of these products also comes with its own supply chain. And this is where all of these supply chains multiply in a way. When you're looking at the attack surface, if you have heard of or seen the movie Inception, it's more like inception of supply chains, and then there is supply chains leading to the other one, and that leading to the other one. So imagine the possibilities can be endless in this case, particularly with respect to the attack surface. And that is why there's no surprise that recently you have seen a lot of threats coming, particularly from the supply chain standpoint. So whether it be solar winds, which actually woke up most of the world to the supply chain attacks while they were already there existing, but this was a huge impact for the entire industry. Particularly for this one, the attacker, they modified the Orion plugin, and then it was trojanized, and then it was also digitally signed, which added to the trust that was there. And of course, it was downloaded downstream by downstream clients. I think close to 18,000 downloads happened in that case, and the impact was huge. There was also another case where you had code coverage, which is a code coverage tool, which is often used by developers in their pipelines. This was a case of leaked credentials in the Docker image, and there was a bash uploader script which was modified, backdoor created, and then it led to extra set of credentials that they could and tokens that they could steal from there. So this was a case where you moved from, as an attacker, from data plane to control plane, and then to data plane, and so on. This was a case of mostly insecure pipeline components. And why I wanted to highlight these is there is no specific pattern that you will see. So it could be lack of integrity, it could be because of the product itself is insecure. Like in this example, it was Kaseya, where the product itself had authentication bypass as an issue, which was the entry point for the attack. Or it could be insecure pipeline components. So it could be anything, essentially, for that matter. Recently, you would also have heard of various attack categories, particularly focused on dependencies. So there are a lot of words being thrown with respect to these. For example, dependency hijacking, or it could be typo spotting and other things, where it's essentially a part of a dependency chain abuse. So the dependency chain where we pull in dependency as a developer is being misused and being misrepresented in a way. So whether you do typos, you create different similar sounding names for malicious dependencies which have similar functionality, and they are all very common these days. There's just one example to show you the impact of these can be equally large. For example, the UA parser, JS, COA, and RC packages, these are NPM packages, quite popular, very much used. These were compromised around October, November in 2021. These have a huge impact precisely for the reason that there are millions of downloads that happen every week for even alone RC and COA packages combined. Here, the issue was dependency hijacking, where the package maintainer's account was compromised, and then the attacker could create post-installation script, which basically was obfuscated TypeScript, which pulled in a batch file, and then that ran, and it was, it was trojanized, so it could actually run the CACbot Trojan in some of the cases. The end result was that it could be used for running, and it was used for running crypto miners and stealing credentials and all of that. Now, whatever be the end results, essentially, when an attacker is already at this depth in the attack chain, there is a lot of other things that can also be brought about or can be done by the attacker. The impact in this case is huge because there are a lot of unsuspecting developers, in this case, millions of them, who would have used this, who might still be compromised because of this particular attack. So what does it actually take to have a robust supply chain with respect to your own product development? When you look at product development, and like we were looking at the attack surface, you, of course, this saying is cliched, but it goes a long way, that you cannot actually protect what you cannot see. So the first step in protecting your supply chain attack surface is to know your supply chain very well, to have the visibility into what all it is made of. So that could be your entire software inventory, your software bill of materials, your entire set of, once it is created, the entire set of APIs which are there, because many times we scale and we forget how many APIs it is that we're working with. There are deprecated versions of APIs which are in use and form a good attack surface from an attack standpoint. And then there can be repositories, registries, artifact trees, and so many other components. I want to pick up the first one. There have been many regulations. There are few regulations, in fact, here, which are necessitating the use of software bill of materials for products, for all the vendors which are there, and for some right reasons. So SecConf will actually give us the visibility into a lot of meta information around the product and the components that it has. So what is it that the software bill of materials actually contains? It will contain a lot of information, including the licenses which are there, copyrights, which are the shared libraries, which is the total set of packages that it is actually consuming and using, any binaries that it is compiled with, other development components, third-party APIs it is consuming, and all of that. And all these information, as you can understand, gives a clear visibility into what could be vulnerable or exploitable. Where should you use it? Mostly in all stages of development, or as far as possible. The simple reason is that the bill of materials keeps changing as and when we keep adding new packages, right? Or we keep on adding, putting it to new images, packaging it for the containers, or at every step you will see that the software itself is changing, and hence the bill of materials should change. And this will help you in identifying and monitoring a lot of known vulnerabilities, first of all, because the packages which are there is known, and hence the vulnerabilities can be known as well. You will know about end of life, you will know about the end of support, you will know when is the next upgrade due for you for many of these packages, and hence the product itself, licensing, and most importantly, the exploitability for the product itself. There are some samples that are there. When it comes to software bill of materials, it is being standardized. There are specifications which are already in play, like SPDX, Cyclone DX, and all of that. And that provides you, as a developer, enough information to make a call around how vulnerable the packages might be. So if you look at it, there are some key information that you can get from the SBOMs that you may have. For example, you will have the licensing information. You will definitely have the creator information, which is very important with respect to attribution. When was it created? Which are the packages that you have? You will also have the checksum, so you know if this version is vulnerable, or how vulnerable is a certain version as compared to another. So all of these key information you can get. Now, one thing I want to cite is some of the practical application of some of these things. While this is a lot of information and you might be wondering whether we should have it or not, if you remember, just a couple of years back, we had Log4j, and that was a pain point for everyone, definitely starting with security teams to the development teams themselves. The biggest and the most difficult activity at the time of Log4Shell, when the vulnerability came in, and the subsequent versions of Log4j that came in, was to identify where is Log4j amongst the whole, piles and piles of the packages that we had and libraries that we had, and also see if it could be exploitable and reachable from our code. When it came to finding where it is, the software in terms of libraries was still okay, but there were also many cases that you have, if you have dealt with it, would have realized that it was also present in the infra components, right? So having something like an SBOM, or having SBOMs for your products in general, makes it much easier, even in case you have 0 days, you have to deal with that, with those in certain scenarios. So let's look at the security aspects now that you have looked at visibility. We know that from the composition perspective, our software consists of not just the custom code, but a majority, there is a bulk of dependencies that we are pulling in from different sources, which could be as much as 80% of the software is made out of dependencies only. And hence, there's a lot of vulnerabilities which these dependencies may have, which we inherit as a part of the software. And that becomes the vulnerability for the software. Now, traditionally, there are many security tools which are highly effective, can tell you which are the vulnerable dependencies, and that can take you a long way. And traditionally, they would give you this kind of information, which is here, like the CV information. If a dependency is vulnerable, which version is vulnerable? It'll give you the CVSS score for that, the risk level, CV information, fix information, all of that. But over a period of time in the last few years, as we have been running dependency checkers, all of us know, particularly on the development side, that this is not as effective as it looks like at the first go. Because you will get, for an existing piece of software, you might get hundreds or even thousands of such vulnerable dependencies where there are different versions which are vulnerable, and none of the development teams are going to fix that mostly. So how do we make it more optimized to dependencies which are actually vulnerable in the context of the application? There are many of the new dependency checking applications that are tools that are coming up that will give you way more curated information. So in the example above, you will see that while you will have the vulnerable packages mentioned, you can also set different kind of filters which will tell you whether, for example, if it is not just the severity, but also can tell you whether these packages are or these dependencies are, for example, popular or not, how popular they are, or how much maintained they are. So these are some of the engineering metrics that they will provide to you, basis which you can do a prioritization of what you would want to fix first versus what can be fixed next. And as a result, some of them also give you some curated list of high impact dependencies that need to be upgraded. For example, you may have 4 to 5 dependencies upgraded, which will treat the 20 to 30 vulnerabilities which are highlighted by the tool itself. That really helps. That can be actionable. That is something that can be worked upon by the development teams themselves also. So while we have the dependencies, we also have the custom code. We have this entire software being deployed multiple times. There are many organizations that have started deploying faster because of course, technology and advancements. But the number of or the percentage of those that actually test for security is still much lesser. So when you look at the custom code, particularly, we have a lot of different kinds of things to check for. One is the secrets that keep being checked in. This is also one of the patterns that you see when you look at the supply chain attack threats and incidents that have been happening for a while now. One of the prominent line of attack is being able to figure out or using OSINT techniques to figure out the keys and secrets, application secrets, which are public for some reason. Either the code base is public or these are leaked somewhere, and then using that to access other control planes, and whether it is the cloud environments, other development environments, or access the components of your supply chain and then carry out further attacks. So while these are being checked in from time to time, one of the immediate ways that if you are setting up security controls in your supply chain would be to have points of detection on the pipeline itself. So integrating your secret scanner on the pipeline is one prominent and a good way to do that. This is something that you can streamline also. You can create templates, you can create regexes, and customize the tool as per your organizational needs when it comes to detecting secrets which are being checked in. Now, apart from that, eventually the idea should be to mature further so that you have more secretless formats of checking in code and basically using with the help of secrets manager. So you may be using a vault, or you may be using any other cloud-based secrets manager. The idea is that you ensure that you don't have to add secrets hard-coded to the code. And secondly, these can be rotated and can be managed over a period of time. There are other aspects to code security for your custom code. One is the SAST. SAST is where you're looking at and scanning your static code for security. Now, why that is important is many times in custom code, while you might have done a lot of threat modeling in the design side and your design might be secure, what happens is your implementation may not be secure. So you will find issues like process injection, command injection, or process scripting and others in your custom code, and those need to be detected. It's much easier to have a SAST on the pipeline itself. So there are many SAST tools which are available, which you can add to the pipeline. But apart from adding them to your CI/CD pipeline, it's also important to integrate that with your development environment through Jira, Confluence, or other dashboards that you have, so that you can immediately assign these issues to respective developers, and that officially becomes a part of your set of tech tasks that you may have as part of development. There's also the dynamic aspect. So once you deployed your application, particularly the application behavior can be tested in various ways. And there are manual ways of checking it, and manually you find a lot of other issues, like for example, business risk issues and session management and other issues. But there can be also a lot of low hanging fruits that you can find with the help of DAS tools, which today can of course be integrated with your CI/CD pipelines and can help figure out those issues across all of these pipelines, across these environments when it comes to that. Now, going beyond the custom code, there is also the infra and the supply chain components that we have been talking about. And one important aspect when you look at the security of that is the component hardening bit. All of these components, whether they are the CI server or the other components which are the infra elements which are there, need to be hardened from time to time. And this is through hardening the configuration of all of these. Many of these are coming with a lot of granular permission sets today. So the example that I've taken up today is for CI server, in this case is Jenkins. But what you can essentially do is ensure that there is a lot of privilege management that's happening to the right extent, for your development teams. So for example, if you have a CI server and agent setup for your CI server, you should essentially focus on distributed builds so that you have specific agents running specific builds rather than everything being run in the built-in node centrally in one place. This helps in privilege segregation. This helps in isolating the attack surface. It also helps in reducing the blast radius, given that a node was actually to be compromised, right, through the code. There's also job restrictions that you can set where you can have specific jobs which are being run on only specific nodes. And on the right, if you see, there's an example where you have now, this is example of a plugin, basically can help you restrict jobs to be executed at a certain node, and that varies from no restriction to, for example, you can restrict it to also specific jobs started by a certain user or a group allowed only to be run on a certain node. So there can be a great level of granularity when you look at that from within the CI server itself, from within the component itself as well. And all of this is available for for many of the CI servers today. The other aspect is also to look at the access controls. There are various intricate permissions which you can definitely define through the configuration or through other network controls that you may have. Your permission set will have things like, for example, whether you can create or manage credentials or not, or whether you can create or manage agents or not in this case, and then you can also build or not. So all of this different level of permissions will be there. It almost looks like CRUD for all these components within the CI itself. While your admin might have all the accesses, for example, your developers will have specific accesses on specific nodes to be able to run the builds for themselves. But even at a network level, when you're defining, it's good to, for example, when you're configuring these components, it's good to look at aspects like, for example, these are not accessible from everywhere. So when we would attack the development environments, one of the best things for us would be to find a CI server which is accessible to us. Then it's a matter of having the right kind of users or default credentials to log in, or try and brute force and things like that. So some of that can also be controlled through things like this, where you allow it only for specific or whitelisted IP addresses. Now that you have input from all these other tooling in your pipeline and then in various other places, you can actually have a centralized visibility in terms of all these findings. One important thing there is to understand the actual unified security posture for your product, because it will give you an overall idea of where things are. So all the different tools can flow into it with respect to findings to a central place, and then you can look at what is the actual status of security for that product with respect to everything, rather than looking individually into different tools, because there are many tools which you will have to work with. It also gives you a centralized view, more control, better profiling, and things like that. When it comes to observability, there are a lot of metrics that you can actually capture and record, a lot of events that you can record from a supply chain and product perspective, and tie it up to your central log management, or SIM, depending on what you are trying to use. So things like what you should be looking for tracking and recording would be some of the events like administrative events, creation of admins or admin access, or even failed login attempts to your CI/CD environments. You could be looking at, once the configuration is frozen, you could be looking at any changes in the configuration that are happening at, of course, uh, anomalous times and things like that. You can also go for like root account logins in your development environment. Um, if there are request thresholds being breached, then those kind of activities can also be done. And all of this can be correlated to your overall, when we talk about your overall security, or with the WAF inputs for these products that you have, or EDR, XDR inputs for these components that you may have, and other SIEM intel that you might get, and be alerted to the right security teams. So we have looked at all of these aspects from a techniques standpoint. So you would be, of course, looking at your design phase from an application perspective by modeling threads around your features or services. You'll be looking at your static code, the implementation thereupon, the dependencies, and secrets and other things in SAST. You will have the dynamic assessment through your security testing or pen testing, and you have your infra components being assessed, where your configuration is being reviewed, but is also hardened, from time to time. So whether it be your containers, or whether you're looking at your cloud security assessment or development environments, all of that will apply to this particular aspect. Now, once you have these or some of these already in place, you can start thinking of how do you mature your supply chain security and what does that really mean for you. Now, there are many considerations when you are looking at maturing the security of your supply chain, and some of the aspects that will determine your the way you want to mature it would be, for example, the external attack surface that you have for your supply chain and your product environments. So it could be the dev interfaces, the third-party services that you're interacting with, just the SaaS attack surface that you might have, things like that. It could also be the code security related issues, like, for example, what are the kind of flow controls that you currently have in your CI/CD environment or not? What are the inflows in terms of data that you're taking up, for example, dependencies, libraries, other things, third-party APIs you're consuming from, infra hardening, the product side of things that we discussed in detail, including the custom code issues and things like that. What is the access control when your product and your supply chain or your product environments are sitting in a certain network? What are the kind of segregation? What is the kind of access control that is there? The outflows, the processes and reviews, for example, what is the kind of process that you might have set or not have in place with respect to your PRs and MRs, right? Are they being reviewed when the pull requests are being raised? Are there any pre-release due diligence that you're performing or not? So all of those things considerations will, and maybe more, will determine what is your current level of maturity and how do you track and move further. All of this, remember, in the context of confidentiality and integrity and availability. So whenever you're thinking of any consideration, you have to think of the CIA aspects, of course, as well as you go ahead. Now, there are many maturity models which are available, and when you go through those, you can follow any of those. Actually, they're quite elaborate and extensive. This is an example of BSIMM, but there is also the OWASP, the DevSecOps maturity model for OWASP. There are other models as well. But while you see there are 4 domains here: governance, intelligence, the software development lifecycle, touch points, and deployment. In this case, I'll not go to the detail because there are quite a few things in each of them. It is good for, in my understanding, it is good for security teams to take this up and run with it, because this is, of course, their day job. As an engineering team, you will not have, most probably you'll not have time to actually take, an elaborate model like this and work with this on a daily basis. Even this model with four domains, around 125 different activities, and each activity will have a different level of maturity that you can be in. It's good for security teams to review, and it's good to get reviewed from time to time, basis some of these models, and structure your assessment on top of that. But as an engineering team, so my thing was, when I was looking at this, was to think from a development team's perspective and think what is it that we can do, and what is it, in which model should we think. So it's not a model of assessing yourself, rather it should be a model in which you should think as a development team or as an engineering team, and how could I make it much simpler so that that analogy can sit, and we can use that as a development team throughout the course of action, in terms of development that we do. That brings us to a more simplified way of looking at it. So we know that, which I call as the space-time security continuum, first of all. So it might sound a little funny, but let's look at the model. So first of all, we have DevOps that we have already established, works on three main pillars, which is people, process, and technology. And in this case, in this particular model, when you're looking at the security continuum, you will look at people, process, and technology as three different axes. So any security coordinator, any security activity generally will have these different aspects in different degree. So you will have the people, the process, and the technology aspects. All of these will be there to a different degree and to a different weightage with every single activity. Now, for example, I will take an example of threat modeling. So threat modeling, it can, of course, people need to be aware of how to do threat modelings, and they should be able to. So there is a training aspect to that and awareness aspect to that. But is there a process which defines that threat modeling will be scheduled at a certain time in your sprint? So that becomes the process aspect. And now, if you're doing this at scale, maybe you want to actually take up a threat modeling tool to automate this so that you have it documented for and something that you can reference in the future, sprints and future, excuse me, PIs for your project. So there is the technology aspect. So there is always these three aspects when you're considering the security activity for your own engineering teams. And while I was thinking of it, I felt there was something missing, and that was the aspect of time. When you are doing DevOps, excuse me, and deploying very fast, the time aspects become very, very relevant. And everything that you do, so any security activity that you're performing is in the context of time, is actually relevant in the context of time, mostly. So if you were to look at it with respect to these two axes, so first of all, you have the people, process, and technology aspects, and then you have the timeline. Here I'm considering the timeline with respect to the plan, design, code, the DevOps loop that we always see in terms of the timeline. So that becomes the timeline that you have, and everything else you can think aligned with that aspect itself. So going further, first I want to link this to from your software to your enterprise. So your security org will have or will contain some of these verticals or different teams, or at least these different activities which are being performed with by a group of teams. You will have trainings, you will have compliance and policy, you will have security baselines that they're defining, maybe a standard set of security requirements which are there. Then you will have your product security teams or secure software development teams which are there. You will have configuration and vulnerability management, intelligence, respond, recover. You will have IAM. This is, of course, not an exhaustive list. All of these can be leveraged in different timelines at different stages in your agile development lifecycle. And for engineering, even where you don't have security experts or security teams to think of this, you can think of it with respect to what is it that you can leverage at different times in your agile development lifecycle. So that makes it much simpler, because then you can invoke the right set of teams or even services internally and leverage that for your product development. When you look at, now I'm expanding on the secure development side of things and the secure development touch points with respect to what we can do on CI/CD as opposed to the timeline itself. When it is juxtaposed with the timeline, it will look something like this. So for example, in your plan stage, You will be doing trainings, which may be more tech stack specific security trainings for developers who are aiming to for a certain tech stack. You'll be defining your DevSecOps KPIs very initially. You'll have security requirements for those set of features that are getting into this, set of sprints. In design, you will have threat modeling on your, feature set of features that you want to do. In coding stage, you will be looking at what are the secure coding standards you will follow. If you're doing manual code reviews, then those are a few things that you will be looking at, secrets management and things like that. In build stage, a lot of these will be automated. So you are looking at secret scanning, dependency checking, SAST and all of that. And you'll get the outcomes from there. When you're doing the deployment, you look at, your container security, and you will also look at things like security testing, but other things like, for example, artifact signing, because you will have artifacts generated at this stage as well. So you will have artifact signing and those things as well that you will have to look at. In operate and monitor, you will have configuration reviews, you will have, component hardening and things like that, and also um, audit logging or feedbacks from these stages will go on to the next sprint, for example. So while all of this looks a lot, it is not everything. First of all, you have to understand 2, 3 things here. Since we are talking with respect to the agile development timelines, the timelines are much shorter. But what we are picking up is, and everything is iterative here, in terms of agile development. But with respect to the security activities we are talking about, it will also happen only incrementally. That means on the incremental code base, which will be much, much smaller. So, for example, even the feedbacks that you get from the tooling will be on that piece of delta and should be only that much, right? So that's much doable. That is bite-sized in a way for the development teams to, imbibe and ingest and move on with. So it is incremental with respect to security, and it's also timely because the right things are happening at the right time. So it will all be happening very fast. And lastly, what you have to think of is most of this, at least 80 to 90% of this will be automated. So because most of this will be automated, it will mean that you are not doing anything by hand. Mostly you might do 1 or 2 things here and there, like threat modeling or other things, where you're doing, manual code reviews. If you're doing, then those will be manual, but everything else is going to be automated and should not be looking like a separate activity or task that takes its own time. There is one aspect also, we were talking about keeping CIA in mind, the confidentiality, integrity, and availability throughout the product security lifecycle that you will have. While confidentiality and availability are not so much standardized when it comes to your build artifacts, there are some standards which are coming up with respect to build integrity and ensuring that, which more or less overlap with your build and deploy stages as well. Now, one such standard is SALSA, which is pretty good if you can adopt that and start working towards ensuring build integrity for the software artifacts that you are creating. It starts with documenting the build process itself, because when you are starting off and you're very new to the process, you will not even have that documented. So having that documented is the first thing, so that it is repeatable and you know what are the processes, what are the aspects of the build process. Next, you will need to have, you'll have to ensure authenticity, and you'll have to ensure basically authenticated and signed artifacts which are created from the build. At the next stage, you will also look at having secure environment. So your host should have security controls, because even if you have signing in place, if your environment is not secure, it may not mean much in the overall context of security. So that is the third stage. And eventually, it's the most mature stage, which is level 4, where you have all of this done, plus you also have your dependencies addressed, vulnerable dependencies addressed, and other components fixed. And, it's the most highest trust level with respect to SALSA. Now, while you're doing all of this, it's important to keep looking at the practices and processes. We are talking about a lot of activities which can be automated directly on the pipeline or otherwise. But there is a lot that needs to be done with respect to practices and processes, and also awareness for people, so that all of this can happen consistently and is not bypassed. So for example, in your sprint planning, have something like, you can have, with respect to threat modeling, and something, you can have something like scheduling or threat modeling as an activity, right? So that makes it a process, and at the same time ensures that it happens for all the relevant set of features. Similarly, in stand-ups, you can have, prioritizing of security tasks. When you're creating stories, you can have security acceptance criteria added to that as acceptance criteria, so that it can be tested by the QA themselves beforehand. You can have sprint reviews, where you review your vulnerability scanning results. Then you can have certain things in retro. You can have things in the showcase as well, and then backlog. You can look at what are the feedbacks you're essentially getting from your previous sprint, and what can go to the next. So a lot of things can happen. You might have to look into leveraging agile and agile rituals, which works best in case of agile development. So finally, now that we are, at a stage where we understand that, okay, we are maturing in various aspects, how do we actually pin that down with the help of metrics? And what would that mean for us in terms of tracking some of those? So while some of those can be tracked quantitatively, others may not be very quantitative. But if you look at some of the technical levers that determine this, it would be, for example, number of vulnerabilities. But as a next stage, you might want to look at, okay, how many of these vulnerabilities that have been detected were detected earlier in the IDE itself, right? So that shows a more advanced, matured state of being. Number of incidents that you find, but then over a period of time, you start looking at, is the mean time to detect or the mean time to recover is reducing or not, right? And in terms of having, for example, high critical issues fixed, you're looking at, okay, when these issues are being identified, is it breaking the build? Is it breaking the build on all the pipelines or not? And how many of them? If there are SLAs to fix issues, are those being followed or not? Or for example, for how many teams? So when you scale up, a lot of these things can become your metrics, which are more practical oriented. There are also things like Salsa, where you will have these levels defined and quantified, which you can follow. With respect to Salsa, it has its own set of parameters that can be followed. The idea is that over a period of time, you move towards a more behavior specific set of metrics. So rather than conducting, for example, threat modeling, what is the frequency of doing the threat modeling might become one of the metrics, or how many security tasks were created as a part of a certain activity, right? Are you proactively gathering the security requirements or not? So are you proactively adding acceptance criteria that leads to security validation or not? So a lot of these things may not be very easy to quantify, but definitely leads to an overall security mindset for your development teams, which will result in further secure supply chains. So to conclude, I would like to say and call out and repeat again around what engineering teams need to think of. Definitely security teams can do a lot of these activities and ensure that many of these are continuous, are automated for them. But for engineering teams, you can start thinking of security as code, so that a lot of these can be automated and can happen at the right development stages, thereby keeping in mind the security continuum that we are talking about, where you have people, process, technology, and time as the relevant aspects of whenever you're thinking of security and secure supply chains. Thank you.